acting properly tonight. So the new year is off to a technical challenge for us, but we'll move on. I did want to acknowledge, though, a couple of things. We're going to have a poem in a minute from a former president. And we have in the room, we have two other former presidents. We've got Terry Lappin, of course, who was president, and we've got Keith Schlotman, who I haven't seen in a little while. So welcome back, Keith. Good to see you again. And he is back engaged and on his imaging journey. So he's going to be especially interested in our first presentation of the night. We've got a number of our technical staff working this evening because of our issues, and Jim Knoll is going to be working the new camera, and Terry is working feverishly to see if we can't get the screen in here fixed. I think on Zoom your screen looks fine, but in the room it is an eye test. So without further ado, David, are you ready?
Yes, I am.
David Levy, another former president, will be sharing a poem with us this evening.
Well, thank you. Thank you all very well. I would like to add my welcome to all of you. I would like to I'd like to welcome all of you, and I'd like to wish all of you a very happy new year. May 2026 bring you only good things and good health, happiness, and peace. My quotation tonight will be the first and last verses from a poem written in 1868 by Sarah Williams, the old astronomer, to his pupil. Reach me down, my Tycho Brahe. I would know him when we meet, when I share my later science, sitting humbly at his feet. He may know the law of all things, yet be ignorant of how we are working to completion, working on from then to now. You may tell that German college that their honor comes too late, but they must not waste repentance on the grisly savant's fate. Though my soul may set in darkness, it will rise in perfect light. I have loved the stars too fondly to be fearful of the night. Thank you very much, and back to you, Ed.
Thank you, David. Tonight we have presentations from two of our special interest groups. Now, for those of you who are not familiar with that term, our organization allows for us to establish recognized groups that can work within the auspices of TAAA that set their own agendas, their own meetings on specific topics that are of interest to the group. And one of our oldest is originally the astrophotography special interest group. It's now called Astro-Imaging. And we have, for these various special interest groups, leaders who manage their agendas and manage the content and arrange special events and so on. We have one of the leaders of the special interest group for Astro-Imaging, Jeff Rothstein, who is going to present to us tonight. Jeff was an attorney in Chicago, came to Tucson via his job, got sucked into these wonderful skies, and then further got sucked into Astro-Imaging. He and Greg Ruppel run this Astro-Imaging group, and Jeff is here tonight to share what they do, what they can do for you. And Jeff, come and share with us.
That sounds good. Good evening, everybody, and thank you for allowing me to join you for a few minutes. So Ed's already given you a pretty good idea of what the agenda is. Can we put it into presentation mode, Bob or Jim? but I'm here with an overview of what we call the AISIG and an invitation. Next slide. So let me begin with a few. Every picture that you're going to see tonight was taken by a member of the group. Greg Ruppel, our fearless leader, specializes in planetary photography. This image of Jupiter and Ganymede was taken with his C11 with a Barlow lens, which gives him a focal length of nearly 6 meters, which boggles my mind. And it takes him about 90 seconds to capture an image like this because he's using rapid video capture and lucky imaging. Next slide. Moving farther out, this is an image from that Ed Bashore took. The hydrogen cloud in the background is Sharpless 129, the Flying Bat Nebula, been known for many decades. The squid there was only discovered about 15 years ago by an amateur who took a deeper image of this target than anyone had ever taken and found this extraordinarily faint object up against SH2 129. Ed takes his pictures with an astrophysics 5-inch refractor at a dark sky remote observatory. Next. Mike Mulcahy, one of our solar fans, took this in his backyard. This was the sunspot that sent out the coronal mass ejection that was apparently about the size of the one that caused the Carrington event. This is just in his backyard with a Daystar filter, cork filter. Next. Now, I've described some pretty fancy equipment, and I know Dave Stern is on the call tonight. This is an image of the Needle Galaxy that Dave took. This was with a C-star. It is, I think, an extraordinarily impressive result for a tiny little telescope like that. Next picture. Another one from Dave, another one from the C-star. This is the mineral moon showing the different colors of the different kinds of soil on the lunar surface. All right. So now let's go on to the next one and talk about what the ASIG is and how we do what we do. So here's our mission statement up here. I would paraphrase it to say we support the, what was the word? Journey, imaging journey of any person from very beginner to the most advanced, sophisticated imagers. And we have some of those really advanced folks, but we also have some folks who've come to us and they show up for a meeting and, hey, I'm new, I just bought this telescope and I want to learn. So how do we do this? Well, we have our own monthly meetings, which we'll talk about in a second. If you've looked at the forum, you might think it is an astrophotography forum exclusively because we are so active, posting images, questions, discussions there. We have created a set of carefully curated beginner resources, which you can find on the TAAA website. We kind of all put our heads together. What did we find the most valuable as we were getting started? It's a great place if you're looking to explore how to get going with astroimaging. We have created a mentoring program. I'll talk about that. But we invite you to participate in that if you're interested. And we have about once a year some kind of a special event. So more to come on all of that. Let's go on to the next slide, talk about our meetings. One more. There we go. So these are first Friday of the month. Ours are third Monday of the month. 7 p.m. We meet by Zoom. Everything's posted on the forum. Typically an hour, sometimes we'll stretch to an hour and a half. Everything is recorded and posted to the YouTube channel. We have our own little playlist within the TAAA's YouTube site. And any slide decks, written materials that are presented get stored in the forum's files section. We've been averaging the past year about 16 attendees at every meeting. Next. So typical meeting, here's the agenda. Introductions is an opportunity for anybody who's never attended a meeting to introduce themselves. We do not require people to sing their college fight song. We then have what we call Beginner's Corner. We reserve time at every meeting for someone to ask a question that they might think is way too simple for a group as sophisticated as all these amazing imagers are. But we take the time, we work through their questions. We then have a substantive presentation. It might be about equipment, it might be about software, it might be about imaging techniques, anything that might be relevant to the past time. And then we have reserved time at the end for image sharing, questions. If somebody's created an image that they especially like, Paul was telling me about this evening, share something like that, which you should share at the next meeting. So that's our agenda. Next slide. Oh, I'm going to say two other things. We're going to get into the topics here. Our typical speakers are our members. Members propose topics to Greg and me, and we'll go out and find someone to speak on it if the member who proposes it isn't the right person to do that. We have open discussions sometimes, like our January meeting. The topic is filters for one-shot color cameras. There seems to be a new filter coming out about once a month that does something different. And there are members who are buying these filters, experimenting with them, and we're going to talk about that. We also bring in guests from time to time. A couple months ago, we had a guest was Brian Valenti, who is one of the leads in support at Astrophysics. He has stunningly encyclopedic knowledge of the hobby, equipment, telescopes, all the software, because he needs to know all that stuff to do his job. He's also one of the best, I think, imagers in the country. So we had a really interesting discussion with him. So here's a list of the topics that we covered last year, and I've marked in red the topics that I think would be readily approachable by and when I say beginner, I mean a rank beginner, not knowing a thing. This one was one of my favorites. What's the craziest, stupidest thing I've ever done in astroimaging? I found it actually a depressing hour because almost all the stories involved a telescope falling over. And that's a pretty painful thought, right? Everybody stretch. When you take an image, it is a truly linear image. And if you know what a histogram is from your cameras, everything is stacked up way on the left-hand side. And you have to stretch that across the histogram in order to create the kind of pictures like Tom Eby took here of M33. So there are many different ways to do it, and everybody has their favorites, and we had demos and kind of a shootout. Guiding for beginners. What is it? How do you do it? What's off-axis guiding compared to a guide scope? Things like that. More advanced topics. I gave a talk with Craig Harding on culling data. You go all night long and maybe a little cloud drifts into a corner. Do you throw that slide away or do you use it? And there are two very different schools of thought. If you want to know what answer we came up with, it's on YouTube. Let's go on to the next slide. A few more topics that we have done over the last couple of years that I think are particularly targeted at beginners, and I'll just let you take a look at that alongside Randy Smith's image of NGC 1333. He lives up in Saddlebrook, so he's got a little darker sky than some of the rest of us, and he's become a big fan of fast imaging Newtonians, and you know, he's an artist. The last one was one of my personal favorites. I sat through the first couple meetings, AISIG meetings I attended. I didn't have a clue. It was like going into a third-year quantum physics class for someone who was a history major. What I wish I had known when I started was really an opportunity to learn from the mistakes of those who've gone before. Now that I've been doing this for 5 years, I could write the book. Because if you can make a mistake, I've made it. Next slide. I mentioned we're active users of the forum, both the chat, which you're probably familiar with, which you can find it at this website. Troubleshooting, advice, sharing of images, all of our meeting announcements are here. And you can join, if you haven't joined the forum, you should, whether you're interested in imaging or not. Let's go on to the next slide. Also on the forum is a files section. And here, AISIG beginner resources, if you can pass the eye test. This is the same material that is linked on the website. We've put it here. And then AISIG meeting materials, this is all of our PowerPoint presentations and the like. Next slide. Here's a list of some of the beginner materials that I mentioned. And next. So mentoring, I had a hand in putting this together because I was the beneficiary of it. Soon after I joined, one of the members, much more experienced than I am, reached out and said, hey, would you like to take one of your images and we'll put it, I'll teach you my workflow in PixInsight, how to use the different tools. We spent about 90 minutes together. It was the biggest acceleration of my progress of any single thing I did, learning how to do this, play with that software. So I got to talking with others and we decided, well, we should make this available in a formal way for others. So we have a database of what equipment, software, processing software, and image capture software various people use. And if you're interested, and say you've purchased, you've gone to Star Arizona where they love to sell you the Celestron C8 telescope with the Hyperstar. We've got people who have used those extensively, can help you get them collimated. It's a bitch, I understand. Am I allowed to say that? If you're using Nina, that's something that I spent a lot of time learning to do, and I'm happy to talk to you about it. So there's details on the website in the AISIG section, and we invite you to take a look at that. I coordinate it. Contact me if you're interested. Next slide. The YouTube channel, this is where we post the videos of all of our meetings, and there recently was posted an index. So if you're looking for something in particular, I urge you to see if there's been if it's been a presentation within the AISIG, because it'll be useful. Next. So special events I mentioned about once a year. 2 years ago, we had an all-day, went for about 8 hours, post-processing session on PixInsight, AstroPixel processors, some of the other software products at the Oro Valley Public Library. Spent the whole day together on a variety of topics, different people speaking about different techniques, as long as it's not me. Last year, we had an imaging contest that you might have seen if you've been following the forum. And here's an image from Charles Hagan, who keeps, I think this is about a 106 millimeter scope that he's got in one of the observatories down at CAC, fully automated. He lives in Colorado. The roof, he put a garage door opener on the roof and sensors, and everything is completely remote. He's an extraordinary imager, and he just graduated from college. We had 3 different categories: deep sky, solar system and nightscapes, judged by some senior leaders of the TAAA. That was an impressive array of images. Next slide. Our next special event, I'm not even sure we've discussed it much at the AISIG meetings, but we are planning an AISIG meetup at Tech that'll be a little bit to one side of a new moon weekend, probably in April. We hope to get as many people down there as we can. Opportunities to show and tell different gear. We'll have some classes, have some socializing. Maybe there's some project we can do down there while we're all there during the day to help out. It's all still being determined. Next slide. So if you're interested, join the discussions on the forum, follow along, feel free to ask questions. This is the nicest group of folks, I mean, just like the rest of the organization, that you're going to encounter. Don't hesitate. Come to our meetings. Again, it's Zoom, so the travel is easy. Introduce yourself. Tell us what you're interested in. Tell us how we can help you advance the journey. If you're interested in mentoring, as I said, give me a call. So that is, I think I stayed mostly on time. Presentation, happy to answer questions. Thank you.
If you've got a question, we're going to give you a mic.
It's on.
I missed it on probably your earlier slide. Where do you meet?
We meet via Zoom.
Oh, everything is by Zoom.
Everything is by, except for the special events where we aim to get together. It's all on Zoom, and the details are on the forum every month. Sure. Anything else? Right.
I was wondering how long the SIG has been existing. I mean, I know it was an astrophotography prior. Has it been for a long time?
It's been for a very long time. I think Ed can talk to that better than I can, but I think at least back to 1990.
It's one of our earliest. We had two early SIGs. One was the astrophotography SIG. The other was the beginner SIG, which has developed into the fundamental SIG. So it's a very, very early one. Terry knows even more. I'll let her chime in maybe after that, because it's interesting because the SIGs have persisted for a long time. And I was just telling Jeff earlier today that one of the things that I had done was I looked back in our old bulletins. You know, we've got newsletters that are posted online on the website going back to 1990. And when you go back and look at the details of what the astrophotography SIG was working with, the issues are the same. The equipment's different. Things are much more sophisticated. Now we're looking at sensors rather than film, but the same kind of issues. And so you've got lots of support still here 30 years later from our AISIG. So take advantage of it if you're interested in imaging the sky. Terry, what are the early SIGs?
We originally had a computers in astronomy group. And I think they sort of, as more and more people got computers, it wasn't so popular to talk about it. And so it sort of evolved, I think, into the astrophotography group, because that was more technical stuff that you could buy and play around with than just computers.
We've been supporting members for many years. Any other questions in the room? There's one right there.
This is going to be sounding ignorant. By the way, it's great to finally see you. But it seems like it's either a C-star or you're spending 40 hours at your computer. Is there something in between? I'd like to, you know, if I was going to get into it, I'd like to get some nice photos, but that's been all my whole life on the computer.
So yes, so it depends on how obsessive compulsive you are about your images. I tend to lean into that quite a bit, and I will spend a lot of time working on individual images. I also spend a lot of time capturing data. I like to shoot for 5, 6, 7, 8 nights on a target if I can. And so you can do anything from, you can put a DSLR on a tracking mount, and which is what I started with, and it amazed me what I could capture. A few images, a little bit of stacking, not using something like PixInsight. There's some free software out there that you can use. So talk to us. We can help you figure out how to meet that. The caution I'll give you is this hobby is like Alice in Wonderland, and it's very easy to fall down the rabbit hole. All right, one more. Sorry. Come on over here. Come over here.
I know you guys use a lot of commercial software, but what's your take on people making their own home-baked software because they just know how to do that?
Well, until very recently, it took quite a skill set to do that. Now there are, I was a lawyer. I created a tool with ChatGPT's help. It's a plugin that I'm just using for myself at this point because I don't trust it. But the ability to use AI to do a lot of that, the detail coding and getting the formatting right with getting the brackets in the right places and all that is really accelerating the ability to do that. I would say, you're young and energetic. I'm not. I want somebody else to do the heavy lifting on the software. But if you've got the aptitude, you absolutely can. Especially some of the programs like Nina, which is one of the primary image capture and system control programs out there, which is free, has plugins. So people write plugins for their specific need, and they publish them, and then anybody else can use them. And it really expands the power of that tool. Welcome.
I just wanted to say one thing, and that is that we're all at different levels in this club. And so some of us are in preschool, I'm in diapers, and the club says amateur, and none of them are amateurs. I know that. So I hang out with everybody so I could learn. But I just wanted to emphasize, I don't think it's irritating me that I don't have the equipment and I don't have, it's a strong word, but I definitely don't have the skills, so I hang out with everybody smarter than me. And there's a bunch of women here that are, so I hang out with them.
Well,
They know who they are.
I do the same thing. I joined this group. It's been 5 years now, but with very little, little bit of knowledge of amateur photography, not astrophotography. And if you want to learn, you can learn. And let me also say, there is a bottom entry level for equipment for astrophotography. You're going to spend some hundreds of dollars, a C-Star's a few $100s. There is no upper limit to what you can spend if you put your mind to it. So that creates an enormous range for finding equipment that suits you.
Does the group host any of, like, members provide the raw stacked frames for others to go around in their free time and try to process to learn their own techniques with data that they don't have?
We haven't. It's a great idea. And I'm going to take that back. I think it's a terrific idea to share. I would love to process images that some of my compatriots in the SIG do, and I'd love to see what they can do with my data, because I'm sure they'll do a better job than I do. But it's an excellent idea. And thank you for suggesting it. Okay.
Do we have any questions on Zoom? No. Okay. Well, Jeff, thank you. Hey. Just before we get started, our next speaker, as I say, I was going through some of the older bulletins, just kind of seeing what the SIGs did. And while I was in the bulletin, I think in 1998, I noticed that there was a new member mentioned. We used to list the new members. It was extraordinary that we got one, and it was Gary Steffens, 1998. Yes. Was that you? Oh, he doesn't know. Yes, that's okay. All right, that's all right. Wait, later on. So Gary has a background in computer science. So he has also a master's in astronomy, though. So it's always been close to his heart, I'm sure.
Yes.
But Gary has recently been involved in something new, and that is creating a new SIG, the radio astronomy SIG. It's only, what now, 6 months old?
Yes.
So an idea that found some other interested parties, was able to successfully be inaugurated into a SIG, and they've now been meeting regularly. And tonight, Gary is going to tell you what they've been doing, and I'm sure get you interested in what radio astronomy can be done as an amateur. Gary,
All right.
please share with us.
I'd love to share my screen, but I can't because it's. Yeah. Aha. Excellent. Oh, which screen should I share? How about this one? Yeah, of course, these things right in my way. Slideshow. All right. Make this go away. I have all these Zoom controls that are like right in my face here. Okay, so back in the wee months of 2025, Jim Knoll sends this email out expressing interest in anybody interested in forming a radio astronomy special interest group. And you know, I've taken a class in this many years ago, and I had dabbled with a little bit, and I thought, my gosh, this would be awesome. So I said, you know, pick me, and several other people joined up too. So I was really amazed, and so that's how we started. And let's go to the next slide. If I can do that. So here's our current state. So we formed in 2025. Our primary lead is Sandy Nichols. He's not here. He's up in Washington State. And because of that, they asked me to do the presentation tonight, and I'm the secondary lead. Our first meeting was on May 29th, and these are all recorded meetings, so you can find those on the TAAA website. Our attendance ranges from 5 to 8, but we have a lot of people that have been viewing the videos, so take that for what it's worth. We meet every the third Wednesday of every month from 7 to 8:30. And I wish I could get these things off my screen because they're blocking. Okay, next slide. Well, some of the goals that I have in our meeting tonight, we're basically new to this. I mean, I've took a class in it like 13 years ago, and it was an interesting class, but I really don't know much about it. And so all of us in the group, we're just all learning together. We're watching videos, we're talking and sharing ideas. I've been sharing some of the things that I've done. So that's one of the beauties of having a special interest group, is that you can learn from each other. Now, some of the things that we've learned along the way is that there's some misconceptions about what radio astronomy is all about and how as amateurs, can we get involved? So what I'd like to do tonight is give you a brief presentation, a brief overview of radio astronomy, how we can participate, and hopefully perhaps inspire you to join our special interest group. So as we all know, at least I hope we all know, atmosphere is very transparent to radio waves. That means we can have these wonderful radio telescopes on the ground. We don't have to put them up on top of mountains to get above the atmosphere. What can we observe? There's lots of things that can be looked at. Solar activity, for example, the sun does give off radiation. We can also detect flares that come and affect the ionosphere. We look at waves that are bounced off the ionosphere. You can actually pick up how the flares cause the ionosphere to kind of vibrate and move. Milky Way structure, this is a really big one. This is my favorite topic. I had no idea that we can actually see the neutral hydrogen in the Milky Way structure, and it's right there for us. It's really amazing. Jupiter radio missions, there's a project called Radio Jove. It's a citizen science project that you can set these up. It's a rather large, very strange antenna setup you put in your backyard, but you can actually pick up emissions from Jupiter. And that's information that we can submit to, I forgot what the organization is. It's part of the Radio Jove group. Getting into more interesting and exotic things, we have molecular clouds astronomers can look at with radio telescopes. Pulsars, you might be familiar with the fact that the first pulsar in the Crab Nebula was discovered by a radio telescope. That's a neutron star that's spinning 30 times a second, which is quite amazing. Black holes, who's seen that picture of the black holes that the radio telescopes created? That's fantastic pictures. And the cosmic microwave background, that was discovered back in the 60s by some guys at Bell Labs, and they were trying to figure out what this weird background noise was. They discovered this incredible remnant from our Big Bang event 13.8 billion years ago. Now, the problem with radio astronomy is that you're talking about long wavelengths, and because of that, the resolution of the telescopes, they have to get really big. And so you can't put like a 10-inch radio telescope out. You're not going to have a great field of view. In fact, a 1-meter dish antenna that I'll be showing you a little bit later, that has a 14.8 degree field of view. That's huge. You hit the same 1-meter telescope, you look at the optical, you're talking about arc seconds of resolution. So that's why these telescopes are so big. I can't see the bottom of my screen, so I'll look up here. So the other thing that's interesting about radio astronomy, and this is something that I think many people don't really fully grasp, is that the antennas, they're not like CCD or CMOS cameras. They don't have pixels. The satellite dish, or the dish is one big pixel. So when you're talking about a 14.8 degree field of view, that's a 14.8 pixel. That's big. And so that's, again, why we want big telescopes, big as much as we can. There's other antenna possibilities. Dipole, there's a loop antenna. I'll talk about that a little bit later. Oh, the 2D images. So one of the things that we do, you've seen pictures with radio telescopes. What they do is they take the telescope when they point at a specific part of the sky, they capture the data and then they move it, capture the data and they move it and they move it. And basically they're painting the pixels, and that's how they make the image. And that's something we can do, except with a 14.8 field of view, you're not going to get a particularly, sharp image that way. Let's talk about the pros and cons of radio astronomy. The first one I think is absolutely my favorite. I can observe during the day. I can observe when it's cloudy. I don't have to go outside and say, oh my gosh, it's going to rain tonight. I can't use my telescope. It's like, who cares? I'm going to stick it out here. I can look at the Milky Way galaxy. Even rainy weather, if your telescope is designed to handle the moisture, the rain coming down. So that's a real big plus. It's also a modest investment to get started. I'll show you a telescope a little bit that costs you about $350, and that's it. That's all you need. $350, get the telescope, you use your laptop, and there's some software. I'll show you a little bit about that. And of course, just like Astro-Imaging, the sky's the limit. And some of these guys, they have these humongous telescopes in their backyard and all this equipment, and it's like, oh my gosh, I don't know how they do that. One of the things, again, free software is another aspect of it that's really great. Another pro is it's got a real scientific emphasis. If you love physics, you're going to love radio astronomy. If you love tinkering with electronics, you're going to love radio astronomy. If you love just looking and discovering that you can see things in the universe that you can't see with an optical telescope, you're going to love radio astronomy. Lifetime of learning new aspects. This thing is just, there's so much to learn. You could just spend the rest of your life learning and just be, I don't know about you, but when I learn things, it's always really exciting to learn new concepts and new ideas. This is one thing radio astronomy can do. It can give you the opportunity to learn new concepts, new ideas, learn how the science of the physics behind what's causing the radiation, the radio waves to be generated, things like that. Okay, so cons. Well, like I mentioned a moment ago, it's an effort required to create a 2D image. I have done it a couple of years ago, and it was a lot of work. The other con is the scientific emphasis. Same thing as a pro. If you're not really interested in science, the scientific aspect, I know making pretty pictures is absolutely wonderful, and I've tried to do it myself. I'm not nearly as good as these guys that Jeff is showing us. But if that's what you want to do, that's great. If the science is not that exciting, don't worry about it. There's always other things to look at. But if you want to, so that could be considered by some folks to be a negative. The low resolution of the telescopes is another negative. You need at least a 3 meter to give you a reasonable resolution for a hydrogen 1, neutral hydrogen. That gives you about a 5-degree field of view, down from the 14.8. There is a large learning curve, and it just depends again on how involved you want to get. If you want to really dig into it, there's aspects of the whole radio technology to learn. There's the aspects of the physics and the science going on. The tinkering, there's a lot of things to learn. But again, if you love to learn stuff, this is where you're gonna really appreciate that. And the last thing I'm gonna call it is we have a different wow factor. If you like pretty pictures, and you look at our stuff, you go, But how many people here love graphs? Just like graphs. If you love graphs, you're gonna love radio astronomy. We have graphs. Okay, so what can amateurs do? This is something that we have done, and I'll show you some examples of the equipment that we use. You can measure solar radiation, bursts and flux changes over time. The sun does radiate radio waves. It's part of the black body radiation. It kind of tapers off into the radio waves. But the sun is so bright that it generates radio waves that you can pick up. Already mentioned the Milky Way 21 centimeter neutral hydrogen, which is 1420 megahertz. You might have heard of that, but again, the idea is that we have so much hydrogen in the galaxy of our Milky Way plane that it takes about 11 million years for a given hydrogen atom to do the energy flip to generate that 21 centimeter neutral hydrogen wavelength. Yet, you look at the images, it's just crowded with data. It's just, there's so much hydrogen atoms out there. Radio bursts from Jupiter, I kind of hinted at that earlier. Meteor detection, one technique there that is to, when the meteors go through, the trail they leave actually can reflect radio waves, and you can actually pick that up. We haven't tried that yet, so we're interested in learning how that can be done. Disturbances in the ionosphere from solar flares and activity, we can pick that up. I'll talk about that shortly. Moon bounce, you can actually measure the distance of the moon by using radio. Some amateurs actually get into maser and pulsar detection, but you need big telescopes, you need a lot of equipment. It can be done, but it's really hard to do. And lastly, there are 5 Astronomical League observing programs. And actually, we've suggested to many people in our group, these might be great starting points They're simple, so very simple projects that you might want to do, and of course, you get the Astronomical League certificate as a side effect of that. So that's pretty cool. All right, let's look at some equipment. The itty bitty telescope. That probably looks like a satellite dish. Well, it is. You could just rip that thing off the roof of your house, take it down, and all you need is can you see my mouse over here? You need one of these satellite signal meters. Those meters are used when you want to line up the satellite dish to a particular satellite. And on the gauge, you can kind of see it there. There's a little needle that'll move when you get a good signal. But you can point this at the sun, actually a little bit to the west of the sun, and let the sun drift through as the Earth rotates, and you'll get a curve just like the sun on the right here. You just go up and down. And once you calibrate these, you can go day to day, and you can actually see how the solar radiation changes a little bit. They call that the itty bitty telescope. This next one, there's a group called the Society of Amateur Radio Astronomers. That's the SARA that you see further down in my notes here. They have they call it a scope in a box. And what it is, it's a 2.4 gigahertz, 1 meter antenna. It comes along with a software-defined radio that you plug into your laptop and a low noise amplifier, which is plugged into the antenna and connects to your software-defined radio. That's it. You provide the laptop and off you go. The software is free. I'll show you a few examples of that. It's $350 at Sarah to buy this kit. You get this tremendously wide 14.8 degree field of view, but you will pick up the hydrogen atoms as they emit in the Milky Way. You can mount it any way you want. This particular picture here shows it just pointing basically straight up, and it's letting the sky just drift through the Milky Way. You could do it that way, or you can change it, you point it at different points in the meridian. Or in my case, I have a small little alt-azimuth mount that I've attached mine to. So there's different ways you can do that. I mentioned, I don't know if I did, my friend Bill, and he's a member up in Flagstaff. I was just up there a couple days ago. He's got a 3 meter dish. As you can see, these are satellite dishes that people don't use anymore. And you can see his sophisticated mount is putting it on a ladder. Can you see that? And he just tips the ladder up to get different parts of the sky. When I was there, he was like, yeah, it's probably Cygnus going through there right now. And you can see this little screen, a little blip going up as it goes over. It was really cool. So let's talk about software real quick. Like I mentioned, the software is free. This is the first one, this AirSpy software. SDR Sharp is made by them. It has a little plug-in. And what you're seeing on the screen here, right here, this is a stellarium picture. And it's of the camera, of the telescope that we just saw a couple slides ago that's pointing straight up. So it's looking straight up. And this is a particular area, M52 in Cassiopeia. And if you look to the right here, this little bump thing, that's the signal. That's actually coming from the Milky Way. This big spike here, that's called radio interference, that's RFI. That's the only problem with radio telescopes is you can get the radio interference. But what's interesting is that this is based on the wavelength, and everything to the right has a shorter, I can't remember. I think it's a longer wavelength. So everything to the right is moving away from the neutral point of 1420 megahertz. So this is probably moving away from us. Again, that's the Doppler shift. They're all familiar with that is. When things are moving away, it stretches the radio waves. And on the left here, there's looks like a little plateau. That's all moving towards us. But this really runs great. This runs under Windows. It's easy to use. I recommend that for everybody who wants to get into it. And I have this URL here that you have to write down really quick, or else it's going to go away. Oop, there it goes. Too late. Sorry. The other software, that's supposed to be funny. The other software that I have used, is called Virgo. Again, it's free software, runs under Linux. It's got a Python interface. If you know programming, you'll be happy. I know Python, I'm happy. Has many utility functions. One of the things it'll do, you can tell it, I'm going to look at this part of the Milky Way with this size telescope. Tell me what it's going to look like. And it'll give you a simulation of the graph that we all love. And if you look to the right here, this is a image that I took of in Cassiopeia, 300-second emission, or I'm sorry, exposure time. And read this dotted line. Can you see this dotted line here? That's anything that's on that dotted line is not moving towards us or away. And everything to the right is coming towards us. And these two humps represent two separate spiral arms that we're looking at, that you're looking through the gas. The spiral, one spiral arm is basically not moving away from or towards us, but there's another one that's moving towards us by what looks like about 33 kilometers per second. So this is the raw data here. This one that looks like a funny hump. This is coming right out of the amplifier. And then you do a calibration. It's very much like doing a flat frame, you know, bias dark frame and flat frame when you're doing optical imaging. It's the same concept. You want to calibrate it so that that becomes a straight line where you're looking at nothing. And what you're seeing then is your beautiful graph of the data. Another software package, EasyRA, runs under Windows, more sophisticated. But these are three example packages that are free that you can use. And that's one of the cool things about this. Now here's another software pack, or not software, different hardware, the Sudden Ionospheric Disturbance Monitor. Sandy has this up at home. Basically what it consists of is a loop, 400 feet of wire looped around this PCB pipe. And what we're measuring is the disturbance in the ionosphere due to solar flares or storms. And what's going on here with this, and this is a kit that you can buy. On the left here, you can see this little round thing, that's part of the kit. What it's looking for is these very low frequency signals that the US Navy sends out to talk to submarines. And these signals go through the water, of course, but they reflect off the ionosphere. And this particular little unit here will measure that at different sites. There's different sites that do this. And it'll actually look and plot out any disturbance to the ionosphere or the reflection of that very low frequency radio waves. This is also a citizen science project that you can get into. Stanford University has a solar center that will take your data. They'll take it every night. Thank you very much. Here's an example. It's another chart. I love charts. Another chart showing a couple of them. You can kind of see it spikes up and then it kind of tapers down. That is a solar flare. That happened on November 10th of last year. And this was from Sandy's data. So that's another example of what you can do with this. So hopefully I give you some idea of what we could do in the club or what we can do with radio astronomy. Here's some details about our meetings. Again, we just started, so we're like 6 months into this. We're not nearly as mature as the Astro-Imaging group, but we hope to catch up someday soon. But some of the things we talk about radio telescope design, software, how to use it, how to install the software. We had a session on history of radio astronomy, which was quite interesting. Radio astronomy has not been around very long. It really came up in the 1930s. And the neutral hydrogen was theorized to emit 21 centimeter wavelength radio waves. And that was detected a little bit right around World War II. So these things are relatively new. Potential projects that are being worked on by members. And lastly, outreach. We talk about outreach a little bit. Speaking of outreach, I went to the Night Under the Stars at CAC last year, and I brought my radio telescope, and I set it on one of the member pads, or not member, one of those open pads. And to the south of me was an array of telescopes with cameras and ASI airs and stuff. And I had so much radio interference. I could not believe it. The signals were so bad. I'm like, what? So the moral of the story is you can't really, you know, if you're gonna do outreach, you gotta like shy away from those Astro-Imaging guys a little bit, you know. We meet third Wednesday every month, 7 to 8:30. Meetings are recorded. And the newsletter has the topics. And I think I have, this just shows how you can get to, if you go to the member-only part of the website, TAAA website, and go to the TAAA links and doc videos, you can come over here and you'll see our pre-recorded videos highlighted in my incredibly red pen there. So, FYI. Our next meeting will be January 21st, 7 p.m. via Zoom. We're going to talk about some antenna design. By the way, we have ham radio operators in the group, and they love to talk about antennas. So, how can you, Sandy? And so that'll be good. We'll talk about that. We've been watching, and we have been looking, again, like I said, we're learning how to do all this stuff. And so a great resource is that Society of Amateur Radio Astronomers, and there's a lot of YouTube videos that talk about various topics. And we started to watch one by this Dr. Wolfgang Hemmann last time, and we're going to finish that. But it's really good. It talks, the whole gamut of radio astronomy, amateur radio astronomy. And I'm going to talk about how you can configure stellarium to show the neutral hydrogen in the silhouette on the sky. So if you want to attend our meeting, and I sure hope you would consider that, just send an email to one of us. And there we are. And that's not bad. I think I'm done. I am done. Thank you. Questions? Or any answers? There's one.
Graphs that you were showing us, do they show primarily the movement of stellar objects or the emission of this H1 or both?
It's capturing the neutral hydrogen, the H1, that is moving in the spiral arms. So since we're outside of the center of the Milky Way, we're not in the middle, we're off to the side. The spiral arms coming this way, there's a component that's moving towards us, and that's what we're capturing. Or if they're going over here, they're moving away. So we're capturing how the movement of the individual sections of the Milky Way spiral arms with those graphs. What I forgot to mention was that one of the cool projects you can do with this is you can plot the speed of the different parts of the spiral arms, and you can prove how the galaxy rotates. It doesn't follow a Keplerian orbit. The farther out you get, you're supposed to go slower, but all the spiral arms go at the same speed. And that's where everybody believed the existence of dark matter. That proves that there's dark matter out there. You can actually, with your radio telescope, with that little 1 meter, you can measure the different speeds and show that the galaxy does have that unique rotation curve to it. So,
thank you.
Yeah. Going once. Young man in the front there.
You might want to get those glasses checked.
Yes.
Looking at what you've shown us, do you ever use an equatorial mount? For
Oh,
radio
yeah,
astronomy?
you can. The problem is if you want a really big telescope, if you want a 3-meter telescope, imagine building an equatorial mount for that. So they're all the big telescopes that can be steered are alt-azimuth. If you look at them, though, they're just, and then there's no field rotation really. Well, the amount of that they're saying there probably is some field rotation, but they have to take that into account. I'm guessing. I've not read about that, but yeah, I've seen smaller ones. You can put a 1 meter on a equatorial mount and follow it that way. Like I said, at home I have a little Ioptron Cube Pro from back in the, I don't know, many years ago, and that just, alt-azimuth, it works great.
I'm sorry, I was just going to say something. My name's Kay Lehman, and I'm Vince Baker's wife. And Vince was one of the original members of this SIG that started up. And he's
Yes.
one of those ham radio operators who loves to talk about antennas.
Yes.
So he was sorry he couldn't be here tonight. So I just wanted to send his greetings.
Thank you. Yeah, he was in an earlier meeting. He did the history of radio astronomy for us. It was really good. So sad he wasn't here.
So where does one go to find a place with the least amount of radio interference?
Ah, that's like the eternal quest. So if you look at the professionals, they have their they have their telescopes situated with surrounding hills that kind of block some of the radio waves. And of course, if you get near them, they confiscate your phone and all that kind of thing. Now, in our case, we're not going to do that. So what I found is that just from my backyard, certain parts of the sky, I will pick up RFI. I have like my network stuff like over here, and I start moving the telescope this way, and the RFI starts increasing, you know. So it's just a matter of finding the best place, experimenting. The other thing I noticed is that my Optron mount has that nice little hand pad. That thing generates a lot of radio waves. So I stick it on the ground and I put a metal can over it as a Faraday cage, and suddenly it's all better. It's high tech.
Other questions in the room?
Jim Noel has one.
So we have one question on Zoom, but before I do that, I do want to offer you guys the opportunity down the road when you're ready to put a nice big radio dish out at CAC. However, if the imagers are out there, how far away do you have to be?
Yeah, we'll put the cage over their telescopes, right? You can't see anything. It's out there.
So would that be a limiting factor? I mean, of course, we have a lot of cameras out there too that would probably interfere with it as well.
You know, what we could do is I can bring mine out there. There's that part that's south and east that's kind of away from everything. We can try that, see how that looks.
Yeah, but I think it would be cool down the road to have a remote accessible big dish out there that you could move and log in from wherever and use.
20 meter would be kind of
Yeah,
nice.
something, yeah. Let's dream big. All right, and on Zoom, Charles asks, he says, with optical astronomy, higher quality images are obtained with more information, either by increasing the aperture or by increasing the exposure time. Is this true for radio astronomy too?
Yes, it totally is. So let me see if I can find the. You probably can't really see. On this graph here on the right, where's my mouse? Go back here. There's a little bit of jiggles there. That's some of the noise that's inherent in the system. This is a 300-second, a 5-minute exposure. I was doing like a 30-second exposure just to see if I was pointing at the right place. And there was significantly more noise. And the left axis is a signal to noise ratio. And I think it's sitting right up close to being at 60 to max. It was probably down more like at 20 or 30. So increasing the exposure time does help give a better signal to noise ratio. And of course, a larger dish would certainly help that too. In fact, you'd have a more accurate, a better resolution of the graph that we all love.
All right, and let's see, from Matthew, you could do RA at CAC during the day, so no interference from the optical telescopes.
That's true.
While they're all sleeping.
That's right. We have to put a sign saying RA in process, go back to sleep.
All right, and just lastly, Sandy is on the Zoom. Sandy, I made you so that you can unmute if you want to chime in or add anything in. Feel free to do so. But other than that, that was it on Zoom.
Oh, this is Sandy. Thanks very much for that. That was a great presentation. Thanks, Gary.
Sure. You can pay me the $5 later.
Have you considered any radio interferometry?
Oh, interferometry. That is a hard nut to crack. I don't know much about it in terms of actually what you need to do, but I understand that the one thing about astronomy is that it's really heavy duty math. I mean, we're talking math like crazy, fast Fourier transforms, things like that. And for interferometry, to get the signals synchronized seems to be the biggest issue. I don't know how that's done, but that's something we're definitely interested in looking into. I know the big observatories certainly do that. That's how they get those very good resolutions like the VLA in New Mexico. But
Atomic clocks.
what's that?
Just get a couple of atomic clocks and you'll be all set.
Okay. I'm sure the club has a budget for that. In fact, when we started the SIG, they said, if you need any help financially. Yeah. Okay. All right. Thanks. Thank you.
Thanks, Gary. Okay, now Dr. Eric Kashka is here to give us a report on the planets. He does this monthly, and his information also appears on the website for you to refer to throughout the month. Go ahead.
Okay, good evening. I start with the three innermost planets, aside from Earth, so Mercury, Venus, and Mars, because all of them are not visible, so it's easy to get them out of the way. And actually, in the middle of the month, they'll be almost the same spot, but also the sun will be there, so you couldn't see them. But on the new moon, on the 18th of January, if there would be a total solar eclipse, you would see all those three planets within 3 or 4 degrees of the sun, so it would be interesting. Maybe some other telescopes could get that, because we cannot see anything so close to the sun. And Mercury and Venus is fast. They are faster than the Earth, so they'll get to the evening sky in February. Mars is slower than the Earth, and so it will get into the morning sky, but only very gradually. So it takes till May until we can see it naked eye. The planet that's up in the early evening, Saturn, it transits now just before sunset, so it's still pretty high up once it gets dark. And a month ago, the rings were essentially edge on, very narrow. But this month they open up quite fast, and the angle of the rings from our side will increase from 0.8 to 2 degrees. So it's more than doubling. Well, if you put that into the width of the rings, it increases from half an arc second to 1.3 arc seconds. So right now the rings are still just like a line. There's no way you can see any width to them. But by the end of the month or so, you can see the rings are actually tilted, and so it's a line of finer thickness. Right next to Saturn is Neptune. Neptune is 3 degrees to the northeast of Saturn. So even binoculars, you have them in the same field of view. And that distance decreases to 1.7 degrees by the end of the month, and then in February, they'll be closest. So every 35 years or so, Saturn moves past Neptune, and that will be the last time in February before it will be next time in the second half of the century. Both planets are still easily visible in the evening sky, so I'll watch that. In Uranus, so the other far planet, was in opposition in November, so it's still good evening object. By 8 p.m. it transits around, and it transits 77 degrees high at magnitude 5.6. So if you have good eyes, you can see it naked eye, but it's a little challenging to find. It's right 5 degrees south of the Pleiades. And so those are easy to find. It's just there are a few stars, so you need to make sure that you don't mix it up with the stars that are fifth magnitude around. The planet in opposition this month is Jupiter on the 10th, about a week from now. And it's near Pollux. At opposition, it gets 46 arcseconds big. So if you telescope, it really shows nicely all the cloud bands and features in the cloud bands. It's magnitude minus 2.7. Only Venus among the planets can get brighter, and Mars extremely rare. And actually, it's so bright that if you are on a very dark side and you see if you can see a shadow from Jupiter, just have some bright ground, and you actually can do that. I've tried that. So it's a bright planet when it's near opposition. Interesting around opposition is watching the moons going around Jupiter, and the largest one is Ganymede. And for example, on the 6th of January, so in 4 days, starting at 9:37 p.m., the shadow of Ganymede will go across Jupiter. It takes about 3 hours or so. And 20 minutes later, Ganymede itself will go across the disk as a transit. And so you have two reasonably big dark spots. One is the shadow, that's completely black, and one is Ganymede. It looks dark because the albedo is only half as much as Jupiter's, but it's not completely dark, so it's more like a gray spot. It's trailing a few arcseconds behind the shadow. So you don't see that very often, and in 4 nights that would be visible. What I found interesting is in January, the sunset delays by 28 minutes during the month. And there's no other month where it does so much. All the following months, it doesn't delay that much. That's the way just the geometry of the sun in its orbit works out. And so at the end of the month, we'll have sunset already a half hour later. Thank you very much.
Thank you, Eric. Okay, I think it's time to say goodbye to our friends on social media.